Welcome back to Seacoast High School's remote trigonometry class. My name is Eric Fearing. I use he, him pronouns, and most students just call me Mr. Today we're working on Competency 1, Benchmark 3. Benchmark 3 says to define the sine, cosine, and tangent ratios. So in our last video, we talked about labeling the three sides of a right triangle with relation to a specific acute angle in that triangle. So you should already know how to label the opposite, adjacent, and hypotenuse relative to a specific angle. Today we're going to expand on that and consider the ratios, the different sizes of any pair of those two sides. So first thing, how many ratios can you write using the three side lengths in this 3, 4, 5 right triangle? You should pause the video and try to write some fractions with 3, 4, and 5 in them. So one of them is 3 over 4. Another one would be 3 over 5. Those are nice proper fractions, 3 over 4, 3 over 5. I like it. I've also maybe got 4 over 5. Are we done? Not quite. We could also do the reverse of these. 4 to 3, 5 to 3, and 5 to 4 are also valid ratios to make out of these three numbers. So in total, there are 6 different ratios we can write among the three sides of a triangle. We're going to go a little bit beyond that, and instead of just using numbers, we're going to use opposite, adjacent, and hypotenuse to specifically refer to these ratios in a given triangle. So I'm going to redraw with a slightly different triangle. I'm still going to call it 3, 4, and 5. And I'm going to label not only my right angle, but also an angle of interest that I'm going to call theta. It's a Greek letter. So angle theta is related to the three sides of this triangle by the way we learned in the previous benchmark. We can label them now. The 5 length side is the hypotenuse, which is across from the right angle. The 3 length side is opposite theta, and the 4 length side is adjacent to theta. So we can write out our 6 fractions again. 3/4, 3/5, 4/5, and then their reciprocals, 4/3, 5/3, and 5/4. Each of these corresponds to an opposite, adjacent, or hypotenuse side, and therefore a ratio of those two things. 3/4 is the ratio of the opposite side to the adjacent side. 3/5 is the opposite side to the hypotenuse. 4/5 is the adjacent side to the hypotenuse. 4/3 is the adjacent side to the opposite side, the reciprocal of our first one. 5/3 is the hypotenuse to the opposite side, the reciprocal of our second one. And 5/4 is the hypotenuse to the adjacent side, the reciprocal of the third one. These each have a specific name, but we really only care about the first 3 of them, because these are the ones we're going to work on the most. If you want to know what the other ones are called, come to my office hours and ask. Opposite to adjacent is what we call the tangent ratio. Opposite to hypotenuse is what we call the sine ratio, and adjacent to hypotenuse is what we call the cosine ratio. You've probably heard in a full-length geometry class the phrase Sohcahtoa, Sohcahtoa, which is a mnemonic that everybody remembers because it sounds funny and they forget what it means. But that is meant to convey the information that the sine ratio for a specific angle is the ratio of the opposite side to the hypotenuse, sine opposite hypotenuse. The cosine is the adjacent leg divided by the hypotenuse, and the tangent is the opposite over the adjacent. I've got a handy graphic for you on Google Classroom, which you can download. If we were meeting in person, I would put this up on a poster and point at it a lot because it's the kind of thing that is helpful to memorize to get through stuff quickly. I would recommend right now maybe you make it your really hip desktop background. So we're going to do a little bit more practice with this as we think about what the homework response is for this unit. To find the sine of an angle, we think about that poster and say, okay, the sine is the opposite over the hypotenuse, which means we need to identify which sides are which in any given triangle. Here's going to be our example, a 5, 12, 13 right triangle with angle theta on the right-hand side here. We can label the sides in relation to theta pretty quickly now. 13 is the hypotenuse, 5 is the opposite side, and 12 is the adjacent side. So what are the 6 side ratios we could write? I've got 5 to 12, 5 to 13, 12 to 13, and then their reciprocals, the improper versions, 12 to 5, 13 to 5, and 13 to 12. All right, so there's the 6. Which ones of those are the sine, the cosine, and the tangent of theta? Not necessarily the easiest thing to think up, but let's just think about what the sine of theta means. From here, sine is the opposite over the hypotenuse. So the opposite side is 5, and the hypotenuse is 13. So the sine of this angle is 5/13. The cosine of that same angle is the adjacent side over the hypotenuse. The hypotenuse is still 13, so that's the denominator, but the adjacent leg is the 12. So looking at our list, this is the sine, this is the cosine, and the tangent is opposite over adjacent, which is going to be 5/12, which apparently I have a habit of writing first when I make my list. So I'm going to encourage you to keep this handy and think about how this is just half of the possibilities, but it covers every pair so that you don't just have a reciprocal included in here. And these are going to be useful for describing the shapes of different triangles of very, very different sizes as we scale up to something similar or shrink it down to something that's actually really handy to use when we describe changing angles, like spinning something in a circle. So today we defined the sine, the cosine, and the tangent ratios. You're asked to do a little bit of explainer for the homework, and I would strongly recommend you write it out on paper, take a photo of it, because writing all of these fractions in a text box on a Google form is not the greatest experience. Thank you very much.